Good evening, ladies and gentlemen. I'm going to talk to you for the next 15 minutes or so about the Bythingson-Hearney Cosmological Theorem, which has been developed here at the Helios Institute by our own researchers in the Department of Exploratory Sciences and Paradoxical Studies, Dr. Nathan Bythingson and Professor Greg Hearney. This theorem can be summarised in two basic statements. Firstly, that the creation of matter at one point can be expressed by the formula knowledge equals power equals energy equals matter equals mass. And secondly, that because initially all of space-time was located at one point, this event of creation can occur at any point relative to space-time and appears to occur around the instance of space where time equals 14.995 billion years, or according to the Hernian system, n, where q equals 14.995. What made the development of this theory possible was the discovery 10 years ago of non-mass thought particles known as cognatrons. You will of course be aware that scientists have been searching for this particle for many years. Nicknamed the God particle, as it is calculated to be everywhere, but it is yet undetectable. Now, what is particularly interesting about these cognatrons is that they have been found to be present in great concentrations wherever matter particles, particularly electrons and quarks, come into existence. As you may know, we have been successful in simulating a small version of the Big Bang within our Large Hadron Collider here at the Helios Institute, which has revealed that these cognatrons are in fact transformed into matter particles when a critical frequency is reached, as we can see here. In order to achieve this, we have had to generate extremely high levels of energy, and our findings show that at the point at which space-time is created, there must be a large source of energy from outside space-time, which is what we call potential inspirational energy. Now, Bythingson and Hearney have been studying these particles since their discovery and have found that the appearance of cognatrons is connected to a cognitive event. During experiments in which a subject was presented with a particularly challenging problem, numbers of cognatrons tended to rise slightly. These rises were shown to be greatest when a subject was asked to solve a creative problem, either in the form of design task or challenge to stimulate their faculty of imagination. From these experiments and from the observations of cognatrons transforming into matter, Bythingson and Hearney developed the equation that forms the major premise of this cosmological theorem, that knowledge equals power equals energy equals matter equals mass. Now, with Bythingson and Hearney's experiments, only a small number of cognatrons have been created, even in the most extreme cases, and certainly not enough to cause their transformation into matter. This leads us to the hypothesis that in order for the cognitive reaction responsible for the Big Bang to take place, there must be a higher intelligence with the cognitive faculty capable of conceiving of everything within space-time, and so generating the required levels of potential inspirational energy. And if space-time is truly infinite, then this means that this cognitive faculty must also be infinite. Though the existence of such a being is an unfavourable theory for many scientists, it is the only possibility when we know that all matter was created in one event. This event necessarily required a concentration of cognatrons and level of potential inspirational energy of an infinite value, which can only be produced through the cognitive functions of some being or organism with both omniscient and omnipotent properties. It also follows that this being must exist independently from space-time. For if we are stating that all matter is created at one point by the transformation of knowledge into mass, then this complete universal knowledge can only be obtained from a position outside space and time, a position from which every instance of space can be perceived simultaneously. From this we can say, then, that space-time in its entirety was conceived and therefore created at one point, in one major cognitive reaction. The second part to the cosmological theorem concerns the nature of space-time, and the point at which this cognitive reaction took place. This part of the theorem is based on the Hearnian model of space-time, which has now been officially accepted as the standard model for space-time. The best way of trying to understand how space-time works according to this model is to think of the 4 dimensions of our physical universe like a film, in which space exists as a sequence of single frames within a timeline, but with each of these frames being only the length of the smallest possible unit of time. These are what we call instances of space. Space and time are relative in this model, but not in the way traditionally understood. Although time is a dimension, it is not a property of space. Rather, the 4th dimension of time exists at right angles to 3-dimensional space. It may help to think of the universe being a sphere constructed from many consecutive layers, each of which is an instance of space, which time traverses. We can see in this diagram, where n is space and q is time, time is represented along the radius, travelling from the centre outwards. And each ring or layer signifies an instance of space. Of course, in reality, space-time is not spherical. Current estimations suggest that space-time forms a shape like the one in this diagram.